Hi and welcome back to Rhinoceros and Grasshopper tutorials. I'm your host Saqib Aziz, and this tutorial we will look at the new component in Grasshopper called Maelstrom. Now we will also model up this pavilion as you can see in the Rhino canvas, but I will guide you through the component which you can find in the transform, showing you some features as a graph mapper, the remap, and also the polar array. We will also see how to actually generate this geometry, creating a loft between two different curves, and then having the freedom to actually change our settings that we have defined here, change the polar array, and we can also look at our graph mapper, showing you this logic, how we can actually generate geometry that is dependent on the graph mapper. And at the end, what we exactly want to do, as I already told you, is to actually model up this geometry and give a slight material to it. So I hope you're ready and we can just jump into this tutorial. Okay, so let's get started. What I'm going to do is I'm going to put off everything that I've drawn so far in Rhino so we can start from scratch. I'm going to go to my shaded view. So the first thing we want to do is quite basic. So we want to generate an array of a point. So for that, the first thing we need to do, of course, is to generate a point. Now a point, in the last tutorial, check it out if you didn't see it. We want to go to the vector tab in our tab menus here, and go to point, and then we can say construct a 3-point. So we have our point here, and now we can say move. So that is our component that we want to use to actually generate the array. I'm gonna hook up this point. That is the first instance that I want to have. And of course, as a default in our move, it's always going to go upwards. So the Z vector has a value here. We want to change that. So we can just say we want to move this point, let's say in the X direction. So I'm just going to type in X, double click on my canvas and type in X, and you will get the unit X. That's what we want to use. We put this here, and you can see now we have successfully drawn 2 points, which is quite okay. And the next thing that we want to do is actually to say, okay, we just don't want 1 point, which is in a unit of 1, but we want to have a multiple of points. For that, we need to create a series, a numeric series. So if I hook up my series command here, it has 3 inputs. Very straightforward. S is defined as the start value. Then you have the stepping. So what is the stepping between each of those points? And then you have how many points or numeric values do you want to have. Right now I have a stepping of 1 and 10 total count of, so I want to generate 10 points, and I create a list, let's say, of 10 values starting from 0, that's my start point, and counting 10 forward till I get to 9. So if I would do 11, I got to 10. If I hook this up, I can already see that I have generated these points. And now what we want to do is we want to control that a little bit. So we can hook up 2 sliders here. And I will say 0 to 20, let's say, that should be enough. So if you do 0 smaller 20, as in the last tutorial I explained that, you will generate a slider that ranges from 0 to 20. So we have that. I'm gonna make a copy and hook this value in N and this value in C. And as you can see, the slider will take over the name that is defined by this component. So this is the step, which is quite nice, so I don't have to actually define it. I'll put it to 1, and then I can, dynamically control my count here. That is already good, and that's just our basic line that we are generating here, right? What we want to do actually is to generate a curve that we can put into our Maelstrom command, which we will get to in a second. But we want to generate a NURBS curve actually. That's what we want to aim. So I'm just going to put in or type in NURB. And this should bring up the NURBS curve, and I can put this in here. So you can already see that I have my geometry here. It is a straight line, and what I want to do now is actually show you the component, the Maelstrom component, just by using this simple curve. So we understand the logic, and then we can build up and derive this more advanced shape that we saw before, this pavilion that I was showing you. So what we actually want to do now is look at this component. So the new components in Grasshopper, you can find most of them actually in the transform, in the morph section. So if you go to transform, you go to morph, and then you have your new features. We looked at the twist in the previous tutorial. Check it out if you haven't seen it. And today we will look at Maelstrom. Now we can just click on this and put it into our canvas, and you see it has a multitude of inputs, and there's a balloon right now telling us that the input G is currently missing because there's no data to collect. We just created this curve, and that is going to feature as our G, our geometry. Notice that every time you have a component and you're not quite sure what it does, you can always click with your right mouse button, click on the middle of the component. You will get to, let's say, a drop-down menu, which will give you this help feature. If you press on this help, a pop-up window will appear, and it tells you, okay, this component is called Maelstrom. What it does is it spirally deforms objects as if they were caught in a whirlpool. That's what this thing does. And then it describes you, okay, hey, we have so many inputs. We have G, stands for geometry. You need a base geometry for that. P is plane. R0 is the number, which is also regarded as the first radius. R1 is going to be our second radius. A is the number, coil angle in radians. So it's basically the angle that this whirlpool is going to rotate this geometry. And R is a Boolean switch for saying if this transformation is rigid or not. And what we will have as an output parameter is going to be a morphed geometry. So quite straightforward, but of course there are some features that we need to take into account. So the most important thing why I'm doing this only with a line first is that you should understand what this thing does. So that's why we just created our G, which is our base geometry. We hook it up, and as soon as we do that, the notification is turned off and the component works already. And we can see that we generated something which already starts to do this Maelstrom feature. Now our plane right now is our world top. So it's going to be our origin, which is always 0, 0, 0. We can of course change that and we will have a different effect. Now if we want to test that, we could again generate a point. We go to vector, we go to point, we say construct point. And because we are on X right now, we could say I want to change my location of my plane to this new location. And if I hook this up, you will see that my geometry is now bended from that initial plane. See? So that also gives me a control of how I want this geometry, or where I want this geometry to be, spiraled around. Now, if I put it somewhere in the middle, you will see a symmetric, more or less, transformation in both sides. But of course, if you just leave it to your 0, start from the beginning plane of your start input, and that will result in different output. So always keep that in mind. I'm just going to leave it here as a, let's say, as an option to look at afterwards. So we have defined our plane. And what I'm going to do here is I'm already going to set up my control panel. So I'm always aware of my sliders, of my dynamic features that I can actually control in my canvas. And here I want to change the name. So I'm going to go to my slider, right mouse button, and click on this empty window and define this is the base point of my plane. So of course you could also say plane base point, maybe a little bit more descriptive, and right now it's 0, and I could change that any given time. So we have done this. That's very good. Let's look at the other features. Now we have R0 and we have R1. This is, in a nutshell, first and the second radius. What does that mean? I'm going to illustrate that now using a circle command. So I'm going to say circle, and I am going to take these values which are in there as a default value. So I have at this beginning 0.1, which is always like trying to not be 0 because that sometimes doesn't work, or mostly, and we will have a second radius. Now my first radius, then I can just type in, let's say 0.1, and this is exactly what I had here. So I'm going to put it here, and this is my first radius. And if I do the same thing now and I type in 10, you will see the second radius. So that is currently my second radius, and as you can see, this geometry that we create with our Maelstrom is actually following these two circles. Everything that comes after this circle is straight, but everything that is actually coming after is already doing the spiral rotation, and the same thing can be said for the first start point. Now, notice if I go to 0, you will have something which does not work. So always make sure that the first radius is bigger than 0. And then I'm gonna hook this up in the R1, so my slider here, and I'm gonna make it larger than my range. So double click on your slider on the end here, not on where your number is, but here where the name of the slider is written. You double click on it, and here I can say my min, max, and my range is then calculated automatically. But of course I can then change my range, and I can just click, press, and move it up, or I can just double click and type in 100. And let's see what happens now. So as you can see, depending on that radius, my geometry will be changed, altered, let's say. And at some point I will exceed the geometry that I actually had. So right now I am perfectly on the end point of my curve, as you can see also here. This is my input geometry, and this is now my outer boundary. And here you can see this is actually pretty much now a straight angle. So if I do a line, I type in 0, this is now in Rhino, or if I just press Auto, this is perfectly on the y-axis, meaning that right now I have an angle of 90 degrees. As you can also see, we have in radians 0.5 times p, which is 90 degrees. If I have my outer boundary catched, this will be met at this point, 90 degrees. But if I start now to actually increase my radius, depending on that, of course, the geometry will alter. It will always try to now have this maximum radius what I give in, and that will define then my curvature. So as you can see right now, it's almost a circular segment that we are generating here. So we are aiming, actually, what we want to do now is we want to limit it always to the endpoint that we have given it. So my current endpoint is always this point here, the maximum of my point array. So I have my series here, and what I want to do is actually take the last value and define that as my radius, because that is the length of my radius, because 18 is here, and you can see in my series 18. So there are, again, a few ways to do that. The most common way that I would see is actually to use the list item. If you say list item, and you hook up your series, depending on what index you have defined, it will filter the value according to that. What I mean with that is basically if I hook up a panel into my slider here, you will see I have a numeric display of values, and this is quite simple to understand. On your left, you will have the index count, basically the index of your item, and on the right side you have your item. So my item here are values ranging from 0 to 18, which in this case also matches the count of my index, because the first instance of any list is going to be 0, and depending on whatever you have as a last input, here I have 18. So it's telling me that I have here 19 values if you count it with 0 till 18. And if you type in list length, we can see that we have a total value of 19, because again 0 till 18 is the same as you would count from 1 to 19. Okay, so we have understood that. Now what we want to do is we want to actually say, hey, take the last value. And for that I would have to type in here 18, right? So I take a panel and I type in 18. And if I type in 18, which is this index here, it will filter whatever item I have there. So I put this in here and I will get my 18. So because it is dynamic and we want to change it, 18 is not always going to be the last value, right? So there's a nice trick that we can apply here, is basically to say -1. And if we type in -1, it is the same as, hey, whatever I have as a list, always take the last item that is in that list. So now, if I hook up a panel here and take my list item, if I hook up this here, I have 18, but as soon as I start to actually change it, you will see that these values change accordingly, and every time it will filter the last value that I have in my list. If you're fairly new to Grasshopper, this is always nice to know how this actually works. So that's something that we have set up now, and we can of course change it back. And now this value will be the one that we want to put in our R1. And now also in our radius here, so we can always see what we're doing. And now if I change my count, the proportion of my twist will always stay the same because I've fixed my endpoints there. Okay, good. Now we have done that, so I'm just gonna put this here, and I can just type in, this is my first radius. And my last radius is now numerically defined by my count, which is okay. So we have done that. I'm going to quickly just, disable, just delete that. We don't need that anymore. And now we have understood the first radius, we have understood the second radius, and now we want to look at the angle. The first thing we want to do actually here is to understand, okay, this value is actually given in radians. Now again, if you want to work with radians, that is fine. Just take, you can work with the pi value and divide it accordingly, or you can just set here, if you go to A, click on your right mouse button, you can change it to degrees, okay? And this little icon here will show you, okay, now I'm working with degrees, and of course, if you toggle that back, it will go back to radians. So if I go to degrees, my shape that I had before changed again. What we can do now is create a slider, which is ranging from 0, smaller than 360. And in this way, we have now our angle set also. So if I have the angle of 0, my deformation is 0. And as soon as I start to change my deformation, you can see now, if I go into top view and put off my slider here, my grid by pressing F7, I can also see now how. So no deformation, and now I can do a full rotation 360 degrees, and you can see I have this almost Fibonacci kind of shell here created. And because I have to find my endpoint in a systematic way, it will catch the endpoint now, and a full rotation will result in a full rotation. So keep in mind that 360 is not limiting you at all. I mean, just because we changed our degrees to 360 doesn't mean that we can't exceed it, right? So I could also go here and type in 900. We could then still continue on our rotation. So that is not a limiting factor for you. I just limited to 360 because I wanted to create a full rotation right now. Okay, so this is very, very, very simple, the way that we have understood now our Maelstrom. So that's what it does. So this is our key feature here. I'm just gonna highlight it with pressing Ctrl G. This will create a group for me. And if I press with my right mouse button onto this group outline, I can change how it looks, and I can give it a name. So this is our Maelstrom. What we want to do now is just leave it for now here, and this is our basic engine that we are using the whole time to generate this geometry. Now, we have created one geometry right now. Let's bring in a little more dynamic play to this. And what we want to do now is not have one line, we have a multiple of lines that we can actually control. So if I go back here and set my angle to 1, so we can see our basic geometry, how about we generate the same geometry here, but we do a polar array, so we have a multitude of different lines, spread it across 360 degrees of our base point. And to do that, we just deploy the command called polar array. Here it is. You just press polar array, and this is relatively simple because our base point is the world XY origin. We don't actually have to put something here. But because we have to find it here as our plane base point, we can also just put this PT in the plane. Yeah, so that is our polar array plane. The geometry is also quite clear, is our NURBS curve that we generated, right? So we just put this here, and you will see it already works because what we have here, and the N, which is the count, is a default value of 10, which we again want to control, right? So what we can do is to simply just put in a slider. If you just double click on your canvas, say 0 smaller than 20. I hope this is an N, and now I can control dynamically how many of those polar arrays I want to have. Now let's keep it to 3 for this instance. So I have, if I go to top, I have 3 rotations from my 0 origin point. And I'm going to hook this now, this G, into my G that I had previously, just this NURBS curve inside. Just put it there, it will replace it. And now we can already see in the top, if I change my angle, you can see now I have actually 3 curves that are doing the same rotation, but offsetted by an angle that we defined. So if I set it back to 360 here and just go to my end, you can see this, every curve now, this curve for instance is actually rotating like so, and continuing on. And now you can just play with this value here with our count. And if I bring it, let's actually put this one on here, so we have some more space. So after my base point, I define my polar array. Because we already have a count here, we actually want to make sure that we understand this count. So I'm going to double click here. You can actually double click and change the name also here. And I say polar array count. And this way we have now this slider defined. And actually I want to keep these guys here, group these 2 guys. I say first radius and I say angle, which is understandable so far. And well, there you go. We have now a little bit more interesting logic, and of course you can now play with the count. You can just go crazy with that, generate how many polar arrays you want to. That is something you can now basically just control yourself, so depending on what your task is. And we have brought a little bit more features to that, a little bit more game, let's say, but now we want to bring in another dimension to it, because right now we are only working on a XY plane and we want to actually move it in the Z direction. And here's where we're going to make it a little bit more interesting, again using our graph mapper. Now let's continue on with that then. So what we have here is a series of values, as we have already established, right? So if I put a panel here to my series, you see I have a series of numeric values. And because they are numeric values, I can change them in the sense that I can control them and reinvent, let's say, the range there. And that's what I want to do now. The first thing I want to bring in is actually the graph mapper itself to make that more interesting for you. So I have talked about the graph mapper in the last tutorial, so I'm going to concentrate this time a little bit more on the remap function. But check out the last tutorial where I talk about the graph mapper more in depth. Here I just want to put in a graph type first. So I'm going to go on this component, click on my right mouse button, go to graph types and define, let's say, the sign, for instance. Yeah, we have the sign now. And like in the last tutorial, I told you this is now ranging from 0 to 1 and 0 to 1. I could, of course, double click on this component, change it, but that's not what we want to do. We want to leave it as it is, because we don't want to change every time we put in a different value here. And what we want to do is we want to remap more or less these values into a numeric domain of 0 to 1. So the input is defined always in one range, which can be understood by the graph mapper. A quite handy way to do that is to use the remap component. So I'm going to bring in the remap. It's called the remap numbers. So for me, it was very crucial to get to know this command. I think 2 years ago I was quite blown away by it, because this enables you so many features that is almost insane. It becomes like a typical routine that you always go through if you're working in Grasshopper. So you have a list of values, whatever values there are, numeric values that is, yeah. You plug that into your vertices in your values, sorry. And you have to define, okay, what is my source domain of these values? And the source domain is actually always the min and max of your value, of your list. So my min is 0, my max here is 19. my lowest number and my highest number. In order to make that more dynamic, I can just type in bound, and there's a component called bounds. You just bring it on your canvas. You just hook up any list you want, numeric list that is, to that bound, and what it will do is it will define a domain and will tell you, hey, the list that you just gave me, the min is 0 and the max is 19. Now your range is from 0 to 19, and that is my source domain. So I can just plug this into my S. And now I have a target domain. As you can see in T, there's a target domain. And as default, it is always set to 0 to 1, which is perfect in this case, but we could also just change that by defining it ourselves. Now there are two things that you can do. One is a simple way is to say, okay, I just put in a number slider saying 10, for instance, and I put in 10. I'm just gonna hook up actually a panel here so you can see what I'm doing. Just gonna put this away. So this is my remap list, and let's look at the list that I actually gave in, which is my series list, yeah. So I have my series list and I have my remap list, and now let's look at this. I have said, okay, I want to have my target source domain is till 10. Now it will take those 19 or 20 values that you have defined here, and it will remap them numerically to match or to count them from 0 till 10. And it will give them, like, these values will, you know, increase by a numeric value or stepping that is calculated by this remap. So if I have my target and I just put in one slider, the domain will always go from 0, which is always fixed, till the slider's number, in this case 10. If I go down till 1, as you can see here, the values here change. So 3 is always going to be my max, which I reach here. And if I go to 1, the numbers that I have here, like these 20 numbers, will now range from 0 till 1. In that case, I have basically said that my stepping is defined by a value of, let's say, 0.05 something, yeah? Actually, this is the stepping, and this is then how it is going to iterate through those lists, creating 20 values ranging from 0 till 1. That is how the remap actually works. So you just define a list with n number of values, you define the source domain of that, and then you hit a target value. So this is how you could do it, but then you are limited to always having 0 as a fixed number. You can also create a domain. Let's just type in domain, and then you have your construct domain, sorry. So you can also just say construct domain, and here you can again put in two values. So if I put in here 0, and I put in here 1, you have the same effect. Now I'm defining this domain by 0 and 1, and this is how this this list is going to be remapped. Of course, now I can go here and change that. Let me just set a higher number. So let's make it, I can go to 21, and my lowest now is not 0, but it's actually 14, and you can see my starting is 14 and 21, and I have 20 values that are remapped between 14 and 21. And of course, if you exceeded 21, it will go downwards. So I start by 28 and go to 21. Okay, so I'm just gonna leave it here because this is going maybe too in depth, but this is how I create this remapped value list. And I can just leave my default setting from 0 to 1 and just hook it up into this graph mapper. And there you go. Now I have a value list that is defined, and the graph mapper then changed those values into a graph type, which is not linear anymore, but it's that graph that I give in. And I can again bring a remap here. And now I have a value list that is a source domain from 0 to 1, because that's how we defined it. And now with the T, actually, I just want to define the height, because that's going to be the values that I take from my height. And I'm going to show it to you in a second. We can just do it. I'm just going to type in 20, hook it up to my T. And now these values have been modified again to range from 0 till 20. What I do now is actually I can just say move here, and I want to move my points that I had before, these points. I want to move them in the Z direction. So I hook this up, I hook my values up. So I have my move command, and I'm going to say that I want to move them in the Z direction. I have two outputs here in the remap function. One is the mapped values, and one is the clipped numbers. What does that mean? Now, every time if your graph mapper exceeds your lowest domain, which is, let's say, 20, and it's actually 30, it will still be represented in this map. So if my graph does something weird and the values exceed 20, this value list will have that also included. But in my clipped list, I only have the values clipped till 20. So everything that's above 20 will be clipped till 20. So it will be revalued, let's say, to 20. And that's what am I going to use is the C. I'm going to put it in my F count here. And now I can just put in my points. And you can see what happens is that I create this graph now. And I can, of course, control it with my T parameter, which is actually the Z height. So that's what I'm going to type in, the Z height. And I can now, control that, make it slimmer, make it larger, depending on what I want to do. I'm just going to keep it at 13, let's say. And this is my Z height now. So if I hook up this now to my NURBS curve, it will generate a different NURBS curve because it will now go upwards, as you can see. So I can now just put this off. And now what we did, we brought in a different dimension. Now our geometry also moves upwards. This is now our input is this curve. And then we, of course, do a polar array. So these are our curves that we have polar arrayed. And then we have this component that actually does the deformation. So that is already quite good that we came till here. And now the cool thing is, of course, you have everything set up and you can now just start to play with it. So a cool feature that I find with this graph mapper, for instance, if you have your sine curve, is that you can just control it and make a dynamic kind of fluid motion here. As you can see, it's like a bird spreading its wings if you want, yeah. But that is just by controlling this graph, because the graph is changing. Also, my input or my output points that I moved are accordingly changed, and then my polar array is triggered and also my Maelstrom. So you see, everything you do upstream will affect downstream also. So if this is maybe too wild, you can go back, change it, define it the way you want it. You can of course change the graph type into anything you want, and then play with that, generate the geometries that you feel comfortable with. So I'm just going to go back to the sine, because we wanted to do the pavilion, right? So I'm just going to go to sine and just leave it as it is for now. And now what we want to do is actually, we are almost done. We can, of course, play again. We can change the rotation. We can change the first angle, or the first radius. We can, of course, construct more polar arrays. But what we want to do now is actually play a little bit with creating loft surfaces. Now we have our deformed curves and we have our original curves, right? And that's what I want to use to generate a loft. Now if we type in loft, it won't really work if we just supply our curves. So if you bring our 3 curves, it will do a loft between them. And if I bring in this command also, it will actually replace them and create a loft between those 3 curves that I have defined. If that is your goal, this is how you would do it. But of course, if you now put in both values, so if I always just put 1, it will just replace my input in this component every time. What I have to do is actually I have to press and control my shift button. You will see that I generate a little plus icon here. And if I put this in now, I have both of those inputs put into that list. Now if I have done this, you will see that I get an error. My component turns red, and if I click on this balloon, it says loft could not be constructed. Now it is quite easy to understand why this is happening, because I am giving 6 curves and I'm not really defining how this loft should be done. I have to really define that because Grasshopper can't figure this out itself. What I want to do is I want to always take one of those lines and loft it with one of those lines, right? And the way that I want to do it is actually if I do a list item that we have seen before, and I bring my list item here and I generate a second list item. I can just turn this off quickly with my Control Q short command. You will see that this is actually the first item of both of those lists. And if I put in now, these two guys, they actually perform a loft. And that is quite nice. That is actually what I want to generate. But this doesn't work if I have multiple inputs. How can we solve that? Now, of course, we could do it a more, let's say, unelegant way. We could just go in our list item and just click here, zoom in, do our plus signs. Because we have three inputs, with three curves, we could just do that. And we just take the second index and we create the loft. And we can do the same thing with the last index and we create a loft. And we generate this shape, as you can see. Very straightforward. But of course we want to learn something here. So the way to do that is actually we have to create grafted lists. So we can just type in graft. And just going to do that one more time before we look at that. So what we have done here is we have taken these three curves and we have given them a own list. Yeah. So as you can see, I have three lists with one item in them. And I'm just going to press on the T here and say simplify, just to make the list more simple, because we have a nested list before. As you can see here, there are some kind of nestings going on. We don't want to understand that right now. We just want to make sure that our list is clean, simple, and that's why we hit the simplify. And then we see, okay, we have 1, 2, 3 lists, and in each of these lists there's one item, individually one of those curves. And now what we can do is, because the list count and index number is the same of both of those lists, we can actually merge them together and bring them into one list. Both of these curves should go into one list now. And we just simply do that by saying merge. You can just type in merge. That's the command that we need. We put in our first list and we put in our second list. And we want to make sure that this is now only, because it only has 2 inputs, we just want to make sure that we delete this number 3 here. That way, in that way, we just result in a more cleaner scripting. Now, what happened here is that it merged those 2 lists, as the name implies. These 3 curves, each with this 3, and these 3 curves, each with the 3, have been combined in such a way that this line is connected with this line, and this line is in one list with this line. And what that enables us to do now is that we can just type in loft, hook up these guys here, and we have now 3 individual lofts, which work perfectly fine. And that is almost it for our Grasshopper part. So what we have done here is generated a logic using the Maelstrom. I'm just going to do a preview here. I'm just going to do a custom preview. Look at the last tutorial for this also. I'm just going to put this here, disable it, Control Q, and leave this default color. And go to your rendered view. This should result in a much nicer view of your object that we have generated. And now you can see this is the geometry that we result in now. Okay, so if you go back, we can of course do anything we want to it. We can just change it at any given point. We can, deform the geometry, make it change the graph type. We could change the height at any given point. We could make it larger. We can make it like a tower if you want. We can make it much more flat. Just going to type in 13. We can also change the angle. Now we could say instead of 360 degrees, we want to actually just have 180 degree turn. And that is actually what we need now. So I would just say, just do that also. You will have your 180 degree. And we could change our radius, inner radius, to, let's say, this doesn't really make a lot. I could just type in 1. So we take our first radius as 1, and you can see that it slightly changes the shape because, of course, our starting point radius has changed. And we can, of course, change the count. We can, go totally nuts here and generate this very, very complex shape. We can just also go here and say 3, which we could also play with is a plain base point, and just change that to see what happens, and you will start to see a geometry beneath here. So if I go here, you can see that this is now changing. I'm creating actually something that has a base point here and then geometry going top on the bottom. So again, polar array, bring more complexity to it, and you can see that this changes as well. So let's keep it to 3. Let's keep that to 0, sorry. And of course, you have your first initial steps, which was to define your stepping of your points, which controls now the shape, as well as your control points, which you can then use to generate that. Okay, so we could of course continue on. In my there's an advanced section here where you can actually generate these geometries. So if I just quickly put this off and put on my advanced section here, there's a way to actually clip or cut off our surfaces that we don't want for our pavilion that I showed you before. But I think this is going to, be a little bit too much for our exercise that we wanted to look here. So what we're going to do is actually skip that. Maybe I will do a separate video for this, because this is really advanced and I'm not sure if this is suitable. And we just want to bake whatever we have here and bake it. Default. Or maybe first of all, what we can do is actually, I will bring up my pavilion. So what we want to do is just generate this geometry here, yeah? So this very simple pavilion, and the settings, as we can see, are the ones that we have just chosen here. So just make sure that you have the same settings. You can also take other settings if you want to play a little bit around. I'm just gonna say, okay, whatever I have here, just create a new layer. Let's say test, and turn off my pavilion and just say bake it to the test. Okay, and there you see we have baked this geometry there, and now we can just put off our grasshopper because we don't need it for a second, and now go to Rhino and look at our geometry there. So I'm just going to go to Arctic mode, and what we can do now is start to trim off our surfaces that we don't need. Maybe you're already happy with that. I want to generate something more which actually culls away these wings here. So I'm just going to click on this geometry, type in trim, and trim off everything that I don't need. As you see, just select one surface and then say trim, and trim off these surfaces. Should be relatively straightforward because we just have 3 instances. And there you go. So we already created this pavilion-like shape. And now what we could do is actually define where we want to cut this. And we could go to front. Here you see the geometry in the front. We just take a line. We say 0 and just define the line. We can then move it. And then just take this line and move it upwards until you're happy. Let's say I take the value 2. So I moved this line up 2 meters from the start where this was headed, and I'm just gonna say trim off my legs here, and what I result in is this shape. So we have constructed this pavilion with very few steps in Rhino, and if I go back to my pavilion here and go to my shaded, I go to my rendered view. The reason why this is looking different is because I took my surfaces and I just gave them a different material. You can also just do that. Just select them, and then you can go to material, drop down menu here, and then say use a new material. And then you could go to any of them, or you could go to more types. Yeah, just dive into this folder here. Maybe I want to go to metal, satin brass, and well, that's how you would change it, if that is the color you want, of course. Yeah, there you go. So we have constructed this pavilion by understanding how to use the component in Grasshopper called Maelstrom, set up the geometry, and what we are able to do now is we can really freely play with this geometry and create different types even, or different logics. But I think you get the basic understanding of how this component works and how you can actually use that to actually generate geometries which you can then use in Rhino. So I hope this was interesting for you. We will continue on with the other components in Grasshopper that are new. If you like this channel, please subscribe to it and give it a thumbs up. And I hope I see you in the next tutorial. Thank you very much.